Hi guys, welcome to another video of physics. In this case, this is the other problem about motion in one dimension. Remember I said that the motion in one dimension uh, could be a line from left to right or another object, for example, going down. Okay, that is one dimension. So in this case, we got an helicopter which height is 10,000 feet, drops a box that falls with an acceleration of 10 meters per second square. Well, this data is really important. I'm going to underline this too. Feet, okay, the parachute takes 8 seconds to open, okay. I'm going to underline this one too. And from there, it descends with a constant velocity. Okay, this one is important too, until it touches the ground. Assuming the box is moving vertically downwards without air resistance. Okay, and these are the three questions. What is the velocity of the box when opening the parachute? What distance does it travel in that period of time? And what is the time that it takes for the box to touch the ground since it leaves the helicopter? Okay, so I'm gonna do a little drawing over here. Let's say this is the helicopter. I'm sorry for my drawings, they are not the best, I know. So this is the helicopter. And from this height, that is 10,000 feet. Okay, 10,000 feet. Okay, it drops a box. Let's say this is the box and it's falling vertically downwards. Okay, in a straight line. And for example, 8 seconds later, it's going to open the parachute. Let's say that here is the box. Now with the parachute, let's say that it's gonna be something like this. Oops. Okay. And for this point, it will remain falling down until it touches the ground. Let's say that this is the ground. Okay, and in this point, it's going to touch the ground. Finally gets there. Okay, something like that. Now, for example, there are very important things to consider before we begin with the problem. So from this point to this point, we got 8 seconds. Okay, and for example 10 feet, okay, this is the total height. Okay, and this box has acceleration. Okay, now when the parachutes open, now it's gonna have how can I say, it's gonna have constant velocity. Okay, so for example, let's do this. Let's say that we're gonna have two parts. So this is the first part when the object has acceleration, and this is the second part where the object falls in at constant velocity. So let's change the color over here. So okay, at this point we got acceleration, and that acceleration is going to be minus 10 meters per second square. Why the negative, guys? Well, remember, this is a vector. Acceleration is a vector, and the motion, it goes down, and the acceleration of the fall is going downwards. Remember I told you the reference system, everything that goes up is positive, everything that goes down is negative. So in this case, for example, well, the acceleration goes downwards. That's why the acceleration at this point is negative. Now, another important thing is this word, drops. So in the first stage of the problem, when I say the first stage is the problem, the stage where it has acceleration, okay, there is initial velocity and it says drops a box. So that concept is going to refer as you let go of something. And when you let go of something that goes down, the initial velocity is always 0 meters per second. Okay, so we got the time, that is 8 seconds. Okay, so the first question that they asked, what is the velocity when the of the box when opening the parachute? So the final velocity, that's the one that I need to find. Final velocity. Okay, what's the final velocity? Let's just remember that in this point here is the initial velocity, and here in this point will be the final velocity. Okay, and of course it's gonna be a negative velocity because I repeat, the box is going down, so the velocity is a vector too. So remember that the vector has magnitude and direction. The magnitude is the number, and the sign tells me the direction. In this case, going to be is going downwards. Okay, so let's say, okay, eraser. I'm going to erase. What can I erase? Okay, yes, I'm going to erase this. Okay, so I'm going to find the final velocity. I'm gonna write it. Okay, I'm gonna find final velocity. Okay, how much is that? Okay, so here I'm gonna do the operations. So final, first the equation of the acceleration. Acceleration equals final velocity minus initial velocity over time. Okay, so from this equation, I'm going to find the value of final velocity, but I already got the value of initial velocity, that is 0. So I'm gonna cancel it. So acceleration equals final velocity over time. Okay, but I'm gonna do the operations over here because to me it's easier to write and to change the colors and to erase something. If I want to do it here, I mean, it's kind of complicated. So I will be returning to this two screens. Okay. So it's going to be acceleration. I'm going to write again. Acceleration equals final velocity over time. So from this one, I'm going to find final velocity. Final velocity equals the value of the acceleration multiplying the time. Okay. So I'm going to substitute the value of the acceleration is minus 10 meters per second square. That multiplies the time. And the time, as I said before, is going to be 8 seconds because that's the time where the box has acceleration. Okay, so 8 seconds. So how much is that? Let's do this. So final velocity, I'm gonna do it. Now let's do it here. Now I'm gonna do it here. Final velocity equals. Well, before I continue, let me get rid of those things. Okay. Final velocity equals. I got my calculator, and I recommend you to have your calculator at hand. So it's going to be minus 10 times 8 equals minus 80. This seconds is going to cancel with this second square. So the final velocity will be minus 80 meters per second. Okay, and that answer, I'm going to write it over here. In red. Okay, velocity at that point. I'm not gonna write final velocity. I mean, I use the final velocity because that's the velocity of the formula. Okay, but I'm just gonna write the velocity at that point is gonna be minus 80 meters per second. Okay, that's the first answer, and I'm going to circle it. Okay, now what distance does it travel in that period of time? Okay, so I need to find, I'm gonna I'm going to do something over here. Just bear with me, please. Okay. There. So I need to find how much distance the box travel in this period of time. Okay. So something that I really like, for example, there are many ways to do this problem, to consider this problem. So for example, well, first I'm going to transform this 10,000 feet into meters. So how much is that? Okay, I guess it's gonna be, well, let's open Google if we don't know. Okay, Google and feet 2 meters, because I don't remember how much is it. Okay, so 10,000, 1, 2, 3. Okay, 3,048 meters. 3,048 meters. Okay, so one thing that I like to consider is that the moment, for example, in this moment, the motion began. So to me, that is the initial position. Okay, to me, the initial position is at 3,048 meters. So if you see, for example, I'm using the letter Y. Okay, so remember that the equation for final position, we use final position and initial position, but that's because we were working with the horizontal axis. In this case, well, now my axis is vertical, so that's why I'm going to use final position but using Y, and initial position using yes, Y. So that means, for example, my initial position will be this one, 3,048 meters. So that means that the position here at the ground will be 0 meters. Okay, so in order to do this problem, for example, this is the initial position, so I need to find the final position here at this point over here. Okay, so I need to find the distance that the box travel in this segment with acceleration. Okay, so I'm going back to the other screen and I'm going to write the formula for position. That is going to be, well, this one I'm going to circle it because that was the first answer. That's the letter A. Okay, so then I'm going to write the equation of position. That is final position equals initial position plus initial velocity that multiplies time plus the acceleration multiplying the time square over 2. Okay, so if you see, for example, my initial position in this case is going to be 3,048 meters. Okay, my initial velocity is 0, so that means that I can cancel this whole term over here. So the equation that I'm going to use will be final position equals initial position plus the acceleration multiplying time square over 2. So the substitution will be 3,048 meters plus, and it will be a fraction, the value of the acceleration, that is minus 10 meters per second square. That is going to be multiplied by the time that is going to be 8 seconds. So 8 seconds square over 2. Okay, so let's do it in the calculator. 3,048 plus fraction minus 10, that multiplies 8 square over 2. Okay, equals, okay, this is the final position, 2728 meters. Okay, So I'm gonna write here, this is the position, okay, 27, 28 meters. But that is the height. Remember, this is the height. For example, the height of the helicopter is 3048. Now, when the parachute opens, that's the height, 27, 28. But I don't want to know the height. I want to know the distance travel. So for example, let's say the distance, in this case, the distance will be equal to 348 meters minus 27, 28 meters, because we're talking about heights. This is the initial height and this is the final height. But in order to know the distance that the box travel, well, I need to perform this operation. So let's do in the calculator. So it's going to be 3048 minus 27, 28. Okay, 27, 28 equals, that's it. That is the distance. What distance does it travel? Okay, the distance, oops, let's change the color. Yeah, distance is 320 meters. Okay. Remember, this is the initial height or the initial position, and this is the final position or the height where the parachute opens. Okay, so I just subtract this height, the initial minus the final, and I'm gonna get the distance that the box travel. Okay, so the other question, what is the time that it takes for the box to touch the ground since it leaves the helicopter? Okay, so for example, I'm going to change the color. This is the second segment. So in the second segment, I'm going to have constant velocity because the problem says that. So I got the velocity. The velocity of this whole segment is the final velocity when the parachute opens, and that final velocity, I already got it. So the velocity in the second segment will be minus 80 meters per second. Okay, and also, for example, I got the final position. The final position will be the height, 27, 28 meters. I also got the initial position. Well, let's say, for example, if we want to separate this problem, for example, let's say, when I say that I'm going to separate the problem, I mean that, okay, so now the problem is going to take only the second section. I'm not taking into account the first section, so I only care about the second, and the second section begins right here. So to me, that will be the initial position because that's where the motion begins, in the second segment. So to me, that will be the first sign of motion. That is going to be the initial position, 27, 28 meters. And finally, when hits the ground, wow, that is the final position to me, because the motion begins here and ends here. So to me, this is the initial and this is the final. Okay, the time of the second segment, well, I don't have it, and I'm gonna call it time 2 because that's the time of the second segment. Okay, so what do I need to do? I need to find the time. I need to find the time that it takes to touch the ground from here to here. And when I find that time, the only thing that I'm going to do, I'm going to add it to the time of the first segment. I'm gonna call it this one, time 1, and this is time 2. Okay, so I'm gonna write the equation again, because in this case I don't have acceleration. Well, I'm not gonna write this formula over here, the one for acceleration. I'm gonna write again the formula for position, and I'm gonna write it over here. So final position equals initial position plus initial velocity multiplying time plus acceleration time square over 2. And remember, we don't have acceleration, so this whole term is going to be 0, okay? Because I got constant velocity. A final position will be 0, so this one is 0. And from this one, I need to find the time. I got the initial position, that is going to be 2728. The initial velocity, that is going to be the same velocity for all the second segment, and the time. So this formula will be 0 equals initial position plus initial velocity multiplying time. So this one could be, I'm gonna take this one to the left, so it's going to be minus initial velocity multiplying time equals initial position. So time will be initial position minus the negative value of the initial velocity. If I substitute, it will be 2728 meters over the negative of the initial velocity. In this case, the velocity, that is going to be minus 80 meters per second. Okay, so in this case, negative with negative is going to be positive. So the time 2, because remember we are finding the time of the second section or second segment, will be, let's take the calculator, 2728 over 80. And I'm gonna make it positive because negative with negative will be positive. So equals, so how much is that? 34.1 seconds. Okay, but just remember, time 2 equals 34.1 seconds. Okay, that's the time that is going to take to travel the whole second segment. So the answer of the third question will be just the addition of this time plus this time. So this, I'm just gonna add 8 because that's the previous time, the time of the segment number 1. So the answer will be 42.1 seconds. So I'm gonna call this total time will be 42.1 seconds, and that is the answer of the third question. Well guys, I hope I made myself clear explaining this problem. You need to separate this problem into 2 sections, the section or the segment number 1, the segment number 2. And this is a very good problem. I mean, you got acceleration and you got constant velocity. And I changed the letters. I didn't use X, I used Y, because in this case we are in the vertical axis. And I hope I didn't confuse you with that change. But if you look at it, well, there is no magic, strange magic that I use solving this problem. Okay, well, stay tuned guys. If you got any question or any comment, please just do it in the comment section below. Okay, so stay tuned for more videos like this. Bye bye.